All right, to start with the chemistry lecture, I have two examples, one being aluminum foil and the second being gold. Both of these are elements, however, they are different from each other. Just like oxygen is different than aluminum, but they're all three of them are considered elements, okay? This is how. Scientists have worked really hard to create a periodic table. So the periodic table is organized in a really, really neat way. So with this basic one, this is our first element, hydrogen, okay? It is not a solid, it is not a liquid. It can be, but it is most of the time a gas, which is similar to these elements right here called nonmetals. All right, to understand what is happening in each square is first the number on top. It is called the atomic number. It basically tells you how many electrons are in this element. Moving on, you have the atomic symbol, you have the element name, and then you have the atomic weight, or it's also known as mass. All right, so going down a group, it increases so that the top part are very light. As you get further down, the elements become very heavy. So obviously, the lightest, the smallest element with only one electron is going to be at the very, very top. All right. So our second group is alkaline metals. Then our next group or family is called alkaline earth metals. Okay, you've got calcium and magnesium in this group. This large section right here, which has nickel, copper, iron, and gold and silver, all of these are transition metals. Okay, then it gets a little messy in here. So basically you have your nonmetals, you have your metalloids, and then you have your, you have your metalloids, metals, and you have your poor metals. There we go, poor metals, excuse me. All right, then you have your halogens, and then the most stable, very neat gases are right here, okay? They are called noble gases, and they are noble because as we get further on into the lecture, you'll notice that there are rings. It's getting quite complicated. All their most exterior, most outer electron shield is full of electrons. There's no room to budge. And what I mean by that is, I'll show you. Okay, so real quick, you've got this shield. So these guys have this completely full, and being the second one right here, which is neon, there will be 10, okay, which is cool. So 2 on the inside, 8 on the outside. All right, so what I've drawn here is hydrogen with 1 electron, oxygen with 8 electrons. Okay, so this is very simple, fine, okay? And you'll notice also that the weight is different. It's much heavier than the hydrogen. Obviously, there's a lot more electrons. So with our first valence electron shield, you have 2. That's the rule, only 2 on the first. Second, you can have up to 8. Here, since oxygen only has 8 total, and you have to have 2 on the inside, you have 6 on the outside. All right, so this is why oxygen bonds with hydrogen very easily. So coming down here, you can see this is oxygen again, and you notice that I've got 2 circles empty, and this is where the hydrogen with the 1 electron bonds, okay? It bonds right here and it bonds right there, making the entire ring out here on the electron valence shield full. That makes it a very stable very stable reaction and very stable compound, okay? So basically, it gets a little interesting, okay? So here you've got 1, 2, 3, 4, 5, and 6, just like there is here. However, you see that the hydrogen is now attached in both areas, and basically these two electrons circulate and share. So this is very stable, which is great. And this is why water is basically a neutral substance. All right, so to learn about an equation, you have a hydrogen, so you have one hydrogen, okay, check. Then you have a second hydrogen, check, okay. Then you have just one oxygen, one, check, perfect, okay. So to write that in a chemistry equation, you have H2O, okay. And another way to write it is basically you have 2 hydrogens plus 1 oxygen is H2O. Pretty cool. Very interesting. This 1, if it is 1, it's not usually written. However, just to show you an example that with 1 oxygen and 2 hydrogens, you get water. Okay, thanks.